Hello, today you're going to take vocabulary video notes on the idea of heat, which we've been learning about for the last week and a half. So set up your notebook. Today you have notes when you write a definition, you draw a picture, and then you make an original sentence by yourself. Alright, let's begin. Your first term is thermometer. Thermometer is an instrument used to measure the kinetic energy of atoms. Remember, if this video is going too fast, pause it or rewind it. Below it, write an original sentence that uses the word thermometer. What I would like you to do is also underline the word thermometer within your sentence. Now let's look at a picture. Remember to draw the picture on this left-hand side over here. I'm going to show it to you big, probably covering the definition first, and then I'll move it to the left. So in the picture here, you can see a thermometer. And in the United States, we traditionally use the Fahrenheit system, which is this one right here. For example, today, in the morning, it was like up to 45 degrees Fahrenheit, which is up to here, a little bit lower. But in science class, we use Celsius, which is the other side of the thermometer. Now you may be asking why. Why do we use Celsius in science? And we use Celsius in science because it's easier actually when it comes to like boiling water, and there's some other equations that are easy to remember if you know Celsius. For example, at 0 degrees Celsius, water freezes. At 100 degrees, it boils. Now, if you had to remember in Fahrenheit, you have to remember that at 28 degrees Fahrenheit, I believe, water freezes. That's like not as specific or as easy to remember that 0 freezes, 100 boils. So that's why you use Celsius in science. And there's other things you need it for in science class, but that's one example. The next one is thermal expansion. And we wrote that in our Cornell notes. It's when atoms expand, temperature increases. And in our Cornell notes, we wrote also that when atoms contract, temperature decreases, which is also true. But this part right here is new. Volume also increases, this part right here, as atoms expand. So what that means is that when atoms are moving fast, something gets bigger as well. And this is the reason why a balloon becomes bigger as it is inflated, because the atoms that are being forced in there, the oxygen and carbon from your mouth, or if you're using like a pump, the atoms are flying everywhere and they are moving everywhere. And of course, because they're moving everywhere, they're pushing the skin of the balloon to stretch out, which means that their volume is increasing. So this can happen something like a balloon. Makes sense that it can stretch, but it can happen on something solid like a piece of, let's say, copper or iron. So for example, this picture here of a copper pipe doesn't look like it, but when the atoms start moving real fast, the copper pipe will actually get a tiny bit bigger. It's more difficult for it to expand if it's a solid, but it will expand. So no matter if it's a copper pipe, if it's a piece of plastic, if it's a latex balloon, when something gets, the atoms start moving real fast, it expands. So much so that usually it's a measurable difference. So we can say that the volume is increased. Go ahead and draw your picture of the balloon with the atoms flying around the balloon, expanding, and the volume increasing. Also, below the drawing of your balloon, write temperature increases as the atoms move around. They have high kinetic energy. Don't forget to write an original sentence for number 2. The last idea is heat. Heat is the energy transferred between objects at different temperatures. So in this picture here, you see that the flame, obviously there's more energy being displaced by the flame, moving these atoms all over the piece of, let's say, metal. And then these atoms are moving faster and faster, and eventually the heat will flow all the way to a cooler area. So heat is when energy moves from one place to another place. Eventually it's going to move through the piece of metal, and from the piece of metal to the hand. So heat is just talking about the flow from one place to another, how energy moves from one place to another. So in this picture here, for example, where is the heat flowing? Is it flowing from the ice cube to the hand, or from the hand to the ice cube? Well, ask yourself which one has more kinetic energy. The hand has more kinetic energy. Naturally, you have atoms in your hand that are moving a little bit warm, not super fast, but they're moving. And the ice cube has atoms, but they're not moving as much. So these atoms that are moving faster start moving the atoms in the ice cube faster, and that's what causes the ice cube to melt. But because the atoms are moving from your hand to the ice cube, the temperature in your hand starts dropping, and that's when you can, of course, feel that cold and start, of course, getting damage in your hand. So heat refers to just the movement of energy. In this picture, heat is moving in this direction, from the hand to the ice cube. Go ahead and draw that picture, and then create your original sentence, and then you are done with this part of step 1. Move on to the next step. Have a good day.